Hi guys, time for a new video. So today we're going to be learning two different things. One is perfect squares and two is difference of squares. And they're both categorized into special products. So why don't we start with perfect squares first. So perfect squares is basically like expanding, but instead of multiplying with each other, we're just duplicating it, in other words. So let me show you an example. I'm just going to classify as perfect squares so you guys don't get mixed up. Perfect squares. Okay, so example number 1. Let's do x plus 5y squared. Okay, so you tell me this. This is how I have written it before. And now if I write it like this, did I change up the equation? Did I change up anything? Nope, it's exactly the same. It's basically this, but it's squared, right? So this is just duplicated into 2 because we know that we have to multiply, when expanding we multiply these with these. So it's the same thing, but it's just a longer form, so it's in factored form. That's basically all you need to know about perfect squares, is that when you have something like this, when it's something like this, it's the same as this. And when you're multiplying it, or when you're trying to answer it and change it into factored form, you're basically multiplying everything in the brackets. So x times x, let's just do it quickly. X times x is x squared. X times 5y gives us plus 5xy. Plus 5y times x gives us plus 5xy, and 5y times 5y gives us 25y. 25y squared, remember. Now, as last time, you're just adding like terms. So it gives you x squared plus 10xy plus 25y squared. And there you have it. That's all you need to know about perfect squares. Now let's quickly move on and do difference of squares. Difference of squares is basically when you have the same terms but different signs. And I'll explain what I mean. Let's do example number 2. And oops, let me just write that it's difference of squares. Difference of squares. So, difference of squares, let's do an example. So let's do x plus 4 and x minus 4. So in this, the terms are the same. So there's 2 x's, there's 2 4. The only thing that's different is the order of our operations. So in this one it's addition, this one's subtractions. When you have a problem like this, always remember you're basically adding these two terms. You're multiplying these two terms by themselves, and you're multiplying these two terms by themselves. So x times x, x squared, and 4 times 4, 16. But you don't know what order of operation to put. Is it addition or subtraction? But remember, it's always in difference of squares, subtraction. Whenever you have a problem like that, it's always subtraction. So it's going to be x squared minus 16. Let's do another example. So let's do v plus 8, v minus 8. In this, you're basically doing the same thing as last time. V times v, v squared. 8 times 8, 8 negative 8. I'm sorry, 64. And there you have it. All you need to know. And let's do one with 2 variables. So let's do v plus d and v minus d. Same thing. v squared minus v squared. And if there was a number in front of this, so 5b times 5b, so it'd be 5b squared and minus d squared. And that's it, the lesson. Let me recap whatever we did today. So we learned about special products, which is perfect squares and difference of squares. In perfect squares, it's basically an equation looking like this, and you're just expanding it to this, and then you can change it from factored form to standard form. And difference of squares is when you have a factored form equation in which one is addition and one is subtraction, but they're the same terms. Then you just basically multiply the first two terms by themselves and the second two terms by themselves, and it's the answer. And there you go, all you need to know. I hope you found this lesson useful. Thank you.